Hi everyone, today we'll be taking a look at question 430 on LeetCode called Flatten a Multi-Level Doubly Linked List. So the idea is we're given a doubly linked list which has a child pointer along with its next and previous pointers. So we want to flatten it from a multi-level looking like this with the children nodes just to a straight up one line linked list without the children nodes. So for the reordering, every single time we pass a child node, we go down, add all the way up to the next children node, go down, and then add backwards. So then we'll add the 9, 10, and then we'll add the 4, 5, 6 afterwards. Cool. So since we want to find the deepest level first, this looks like a DFS function. Let's talk about the edge case as well. So if there is no head, return null. Now let's find the deepest child. Let's say child equals DFS. Sorry, not DFS. Flatten. Add the child, and we'll say what next equals flatten head dot next. So let's talk about the first case. Because the children nodes will always come before the next nodes, we'll say if there is a child, we'll do something else. If there is a next, then we'll do something else. So if it's a child, we just want to add it on. So we'll say head.next equals child, child.prev equals head. If it's a next, we want to say next.next equals head.next equals next, and next.prev equals head. And then to add on the next pointers after we add on the children, let's just call it a function add to tail with the child as well as the next node. So in this case, we're going to be adding this 9 and 10 after the 11, 12, and the 4 and 5, 6 afterwards, 9 and 10. Afterwards, because we want to get rid of all the child pointers, we can just say head dot, in this case, child equals null. Cool. Now let's do our operation. So we can say function add to tail using child and next. First off, if there is no child, or if there is no next, return to do anything. Now what we want to do is we want to add the next pointer after, at the end of the child node's tail. So in this case, we can say cur equals child to give a reference to our traversal. And we can say while cur.next, cur equals cur.next. So in this case, we'll end up at the 12 node here. And then we can say cur.next equals next. Cool. And at the end, we just return the head. So let's see if this works. Let's see, something happened. Oh, oops. And next.pre equals cur. Cool. Works just fine. Works just fine. Let's draw this out in Paint just to get a better idea of what just happened. So first off, we're going to go to our deepest child using our recursion over here. So we're going to end up at 11. So the first thing that's going to be taking a look at is 1, 2, 3, and then the first child that we pass by is 7 and 8, and the next child that we're going to pass by is 11 and 12. So that's basically what's happening on line 20. We're just recursing to the next child and then adding that to the tail of our list. So it will look like this initially. Then we work backwards. So 11 and 12 has something afterwards. So we'll go to the next part of the call stack, which had the 7, 8. 7, 8 was followed by 9, 10. So this will be followed up by 9 and 10. And After that finishes, it goes to the next part of the call stack, which is where we were left off at the 3, which is followed by 4, 5, 6. So we just add 4, 5, and 6 afterwards. Cool. Runtime of this, well, we're going through every node at most once in our DFS. So this is O of n, where n is the number of nodes in our original linked list. So with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.